Hello everyone, in this video I'm going to be reviewing ways of simplifying radical expressions. And in this case, I'm looking at one that it's going to take multiple steps as opposed to a straight simplification. So, as opposed to something like the square root, let's do cube root since we're on cubes, cube root of 27 x to the 9th, for example. We said that we can simplify this because we can take the cube root of 27, which is 3, and I can take the cube root of x to the 9th. The quick way is to say whatever our index is, I'll divide that number into the power, and hence x to the 3rd. And this would be our result. Now the difference between this one and what we're doing now is 48 is not a perfect cube. So for problems like this, we want to think, well, what are our perfect cubes? They are 1, 8, 27, 64, and so on. So I say, can any of these numbers divide into 48? In this case, 8 can, 6 times. So what I'm doing with the 48 and then eventually with the variables is I'm going to split this into a term that I can take the cube root of and one that I cannot. And I want to pick the cube root in this case, or any root, the largest one that would divide into the number I'm considering. Now with my variables and exponents, I don't think, can a cube root divide into 4, or 14 for that matter. I'm looking at my 3, my index. So can my index divide into 4 evenly? And no, it can't, but it can divide into it 3 times evenly. And 3 times 1 would give me 3, so I have x to the 3rd and x to the 1st. And what's important to remember with these is when I split it like this, as opposed to my 48, the 8 times 6 multiplied to get 48. Now yes, x to the 3rd, x times x to the 1st gives me x to the 4th, but a quicker way of thinking of it is these numbers, these exponents, should add up to my power up here. That's how we know we're on the right track. So now I say 3 doesn't divide into 14 evenly, but 3 can divide into 14 4 times. 4 times 3 is 12. So I'll split this into y to the 12th. The remainder is y to the 2nd. Again, because I want 12 plus 2 to add up to 14. Now, 3 does divide into 21 evenly, so I don't need to split this. For now, I'm just going to say, let's bring down z to the 21st. So what I've done again is I've split each of my terms, the 48, x, y, and z, into, if they didn't have a perfect cube, into 2 parts, one of which is the perfect cube. So my perfect cubes are 8, x to the 3rd, y to the 12th, and z to the 21st. Everything else is my 6, my x, and my y to the 2nd. So the way I like to look at these is, now I have 2 radicals. Using my rules of radicals, I have the cube root of the first bunch and the cube root of the second bunch. This first bunch, as I said, these are all perfect cubes, so I can divide these, or I can take the root. The cube root of 8 is 2. Now again with exponents, I'll say, how many times does 3 divide into 3? And that becomes x to the 1st. How many times does 3 divide into 12? 4 times, so hence y to the 4th. And the same idea, how many times does 3 divide into 21? 7 times, so z to the 7th. And if you're wondering, you can say x to the 1st or just x. It doesn't matter. But we do have to include our remaining radical. It's still part of the solution. It's just simplified as much as we can. And this would be our result. So with problems like these, again, I recommend if you can't take the cube root evenly, or our index cannot divide into the powers evenly, we split them into 2 parts. Again, with 48, we need a perfect cube that can divide into 48, that's 8. With our variables, we say how many times can 3, for example, divide into 14 evenly. It goes into it 4 times. 4 times 3 is 12, so I put 12 and 2 down here, that's my split. And I said, whatever your split is, as far as the exponents go, these exponents have to add up to the original 1. So 3 plus 1 is 4, 2 plus 12 is 14. You break them apart into your perfect cubes in this case, or perfect squares, whatever it happens to be. Your non-perfect roots. You simplify as much as you can, and this is our result. So try this method when you break down radicals, and hopefully you can come to the same conclusion.